Okay, when you have log equations, a couple things you need to look for first. First of all, make sure that the base numbers, so log base 11 on both sides of the equal sign are the same. If they're not, then you can't solve in this fashion for these simple problems, okay? Then, once you do that, just like if you have 5 to the x equals 5 to the 3x plus 9, once the base numbers are the same, you can ignore them and just solve for the exponents. Well, similarly, once you recognize that the base numbers are the same, you can ignore this stuff and you can just set the arguments. Since negative 2n is smaller than positive 5n, I'm going to add 2n to both sides. 5n plus 2n. And then just divide both sides by 7. Now, you have to be more careful with logs because once in a while it won't work. Because remember, you can't remember what the graph looks like. You can't type negative numbers into log. It won't work. Look at there's no graph on the negative side over here. So once in a while when you get an answer, if you plug it back in, like if that would have been negative 9/7, you either made a mistake or the answer would be no solution. So maybe there will be one like that in what we're going to try. Okay. So notice that they both have base 20, so I can just bring down the argument. Ooh, we have a quadratic. So that means we need to get everything to this side because we have to solve using a quadratic. So we're going to subtract a 2n. Remember, you have to put them in the right order. Subtract a 72. So we'll get 0 on this side, and then we'll have n squared plus 1n, subtract 72. Well, then it's just factors of negative 72 that add up to positive 1. Well, that would be 9 and negative 8. So n plus 9, n subtract 8, and then when we have to solve, the opposite of 9 is negative 9. The additive inverse to 9 is negative 9. The additive inverse to negative 8, what zeroes out negative 8, is positive 8. And then you have to check both of them. If we put negative 9, the negative one I'm worried about. If we put negative 9 in here, that's 72 plus negative 18. Well, that's still going to be a positive number. That's going to be what, 54? And then if we plug negative 9 there, we get 81, subtract 27, also 54. So negative 9 works, and since 8 is positive, 8 should work too. So n is equal to negative 9 and 8, just like that. Okay, this one looks really weird because notice there's not a log on both sides, so that previous method can't be used. But notice what you do have. You have this log expression is equal to this exponent over here. But first use your properties of logarithm. So, well, nope, let's do it this way. Before we can get to this, one way of doing that is just divide both sides by 8. So now we have, here's our base, here's our argument, here's our exponent, and now we can rewrite it as b to the n is equal to a. So let me refresh your brains. This is the argument. This is the base. This is the exponent. So we're going to rewrite this as b to the n. So 8 cubed is equal to the argument. And then we can divide both sides by 5. Let's see. I think that ends up being 512 over 5. So let's see. 8 cubed. Yep. 512, and I'm okay if you leave it just like that. P is equal to 512 fifths. Okay, don't let this freak you out. Even though there's a lot of parts and a lot of numbers to look at, remember, once you get it to log with the base of an argument is equal to n, you can rewrite it as b to the n is equal to the argument. So there's multiplying and subtracting, so you have to add 5 to both sides. Well, then we're going to divide both sides by -2. Well, 16 by -8, sorry. -2 is the result. 16 divided -8 is -2, and that's base 11 right there. So now look at what we can write. Our base, so 11, to our exponent, -2, is equal to our argument. So now we need to get the a by itself. Well, we can add 6 to both sides. So 11 to the -2nd is 1 over 11 squared. 11 squared is 121. Then we add 6 to both sides. And then we're going to divide both sides by -2a. And that's just going to be a calculator keystroke thing. So just be careful with the calculator. I recommend doing this. So left parentheses, and then left parentheses again, 1 fraction. Well, if you want to do divide, if this is going to be a weird decimal, just hit divide, 121, close that parentheses, add 6, close that parentheses, then divide -2. And what we get is a is about -3 and this is where you want to go out to the 10,000th place. Just like that. Okay, now we're back to having logs on both sides. Those are all the invisible base 10. They all agree. But notice what we have here. We have this subtract between two logs, same base. Remember what we said we could do? You could rewrite it, subtract, condenses to division. So x plus 2 over x. Well, now that we have log base 10 is equal to log base 10, we can ignore that, and we can just set the arguments equal to each other. We don't want this variable x in the denominator, so I'm going to cancel it on the left side by multiplying both sides by x. Now we have x plus 2 is equal to 43x. I will subtract an x. 2 is equal to 42x, and then divide both sides by 42. Well, 2 and 42 have a 2 in common, so 1 over 21 is equal to x. This is the same process, but now we're using natural log. So, and remember, with natural log, all of the bases are e. This subtract is going to condense to division. So this is the numerator, always the numerator, and then subtract. This will be the denominator. So this is 5 over x plus 10, and this is ln that invisible base. So now we can ignore the L and the V on both sides. So if you wanted right there, you could just flip both sides. Since this is a fraction equal to a fraction. And then we can cancel by multiplying both sides by 5. Here, I'm going to start it back up here. So now we have x plus 10 is equal to 5 over 30. And you can simplify that right now by putting 1 over 6. And then we're going to subtract 10 on both sides. So x is equal, well, 10 is the same thing as 60 divide 6. All I did is rewrite 10 as 60 divided 6, and I did that so that these two have the same denominator, and then that's easy. 1 subtract 60 is negative 59 over 6. And then you'd always have to remember to check your solution, because once in a while it'll actually be a no solution. Okay, now we have an addition. Well, that means the arguments expand to multiplication. So we have 4 times x minus 4. Ooh, there's not a log over here. Well, what could we write? We know that this is, if that's 1, then, and this base is 6, then that would have been log base 6 of 6. Log base 6 of 6 is equal to 1, so you can rewrite it that way. And then we can ignore, you could have done it the other way. You could have rewritten it as 6 to the first, but we're gonna do it this way. Now look at what we have. We have to do the distributive. So 4x subtract 16 is equal to 6. So we're gonna add 16 both sides, and now you have 4x is equal to 22. Divide both sides by 4. And then these both have a 2 in common, 11 halves. Okay, really quickly, I'm going to erase all of this, and I'm going to leave it like that. I could rewrite it as b to the n is equal to a, and it will be the same. 6 to the first is 6 equals the argument, and remember we did the distributive. It ends up being the same method. I mean, not the same method, it ends up being the same result. If you're using properties, that's how it should always work out. That as long as you're using the correct properties, several methods will produce the same answer. All right, this is another one where this condenses to multiplication. We just did one like that, so that's it for this video.